In this video, I'm going to take a look at a basic proof from 8.2. This obviously involves predicate logic, which initially looks quite confusing, all these new symbols, this new syntax. So if it's initially confusing, you might just simply approach a Chapter 8 problem as though it's really a Chapter 7 problem. And of course, there's a little bit more to it than that, obviously. But if you just get rid of these quantifiers here, if that's a little too messy to look at here, and of course, even without the quantifiers, Chapter 8 is a little bit more specific than Chapter 7 in that it accounts for both the subject and the predicate. But if you can imagine it even without these x's in here, just view it as a simple Chapter 7 problem. Of course, never lose sight of the end goal. If A then B, if B then C, stripping away those quantifiers and imagining it without the x's in there, if A then C, you can, I'm sure, see a pretty basic hypothetical syllogism. If A then B, if B then C, therefore if A then C. So if you strip away all the messiness of this, then this one actually just becomes a real basic hypothetical syllogism. Now again, there's a little bit more to it than that, but that does give us a nice, neat strategy. Now before we can apply the hypothetical syllogism, before we can apply the 7.1 and 7.2 rules, which all revolve around the main operator, we need to get rid of these quantifiers here. The main operator in premise 1 is not the horseshoe. The main operator in premise 2 is not the horseshoe. And for hypothetical syllogism, which we know this is going to involve an HS, for hypothetical syllogism, we need two lines where the main operator in each is the horseshoe, such that the antecedent of one is the consequent of the other. But in 1 and 2 respectively, the main operator again is not the horseshoe. The main operator here is the universal quantifier as it is here. For any x in the universe, if x is an A, then x is a B. For any x in the universe, if x is a B, then x is a C. So before we can apply that HS, we need to get rid of these quantifiers. If the quantifier is the main operator, usually you want to get rid of it. So to get rid of a universal quantifier, we're going to apply universal instantiation. Instantiation gets rid of a quantifier, generalization adds it back in. So we're going to do UI in no real order 2 consecutive times, UI to line 1, UI to line 2. And that's just the justification for lines 3 and 4 respectively. Now when you strip a universal quantifier, you have some flexibility here. You've got some options. You can of course strip the quantifier, and you can change it either to a constant, a lowercase letter a through w, or to a variable, an x, y, or a z. So we've got flexibility here. Could be a constant, could be a variable, but always be thinking one step ahead. Never lose sight of the end goal. After we strip these quantifiers, then the main op in each will be a horseshoe. Then we've got the HS, but we don't want to end up with a line where the main operator is the horseshoe. We want the main operator to be that universal quantifier. So at the end, we're going to have to add this back in. And to add it back in this case, it's going to be universal generalization. Instantiation strips a quantifier, generalization adds it back in. But unlike UI, UG is restricted. UG can only be done from a variable, from an x, y, or a z, not from a constant a through w. So for UI, technically, it could be a constant, but recognizing that the end game here is going to involve UG, we want it to be a constant. X, y, or z, your choice. I'm just going to leave it as an x. So strip the quantifier, and we want, in this case, to change it to a variable, not a constant. So there are 2 consecutive UIs, and again, pretty straightforward here. Now we've set up the HS that we were looking for. If x is an A, then x is a C. Our line 5 is nearly the conclusion. We now need to reintroduce that quantifier. So the end game here, forgot my justification for line 5, 3 and 4 HS, just like a standard Chapter 7 problem. The only difference here is we're accounting for both the subject and the predicate. It's more precise than Chapter 7. Now, 5 UG. Generalization can only be done where that quantifier has previously been stripped. It was there originally. We got rid of it to execute the HS. HS requires that the main op be the horseshoe in each line, and now we're ready to add it back in. And again, UG is restricted. It can only be done from a variable. That's why we switched it to a variable and not to a constant. So add that quantifier back in, and we are done with a real basic predicate logic proof from chapter 8.